Hello everyone. In this video, I'm going to show you how to deploy a scalable VPC architecture on AWS Cloud. Kindly do not forget to subscribe to Edwiki learning channel for future project upload notifications. Without further delay, let's get into the discussion. So you can find the problem statement of this project in the devopsrealtime.com website. And here you can see the VPC architecture, which is explaining to deploy a simple web application with a highly available, auto scalable, and secured by implementing it in the private subnets in the auto scaling groups in attachment with the load balancers. So let me see the project steps here. The prerequisite says I need to have a AWS account. Yes, I just have logged into my AWS account here, and there is a source code that is required to deploy a simple web server. Let me copy the link and keep it ready where I can see the sample HTML based web application code which I can deploy and run a web server on our private EC2 instances. Well, as part of the pre-deployment, we need to create a golden AMI that we can use in your auto scaling group to launch instances, right? So let me go ahead and create one simple EC2 instance to create a golden AMI with the 6 elements that are pre-included, right? From my AWS management console from EC2 dashboard, let me go and launch one simple EC2 instance. I will provide the instance name tag, let's say a temporary server to create AMI. Let me go with the Amazon Linux AMI t2.micro instance type. Let me choose the existing key pair. I am deploying this into default VPC into default public subnets for now, as this is just a temporary server to prepare the golden AMI. So let me wait for a second. Now the EC2 instance is ready. Let me go and get the public IP of this EC2 instance and let me logging into this instance from SSH client putty. I have the shared session where the private key is already attached. So let me go and logging into this EC2 instance. Well, I'm just waiting for the server to come up. Now let me accept this fingerprint verification to add it into the known host file. EC2-user is the default username. Let me switch to the root to become the super user access. So as per the project documentation, I need to have the AWS CLI installed. As you know, the AWS CLI is available by default on Amazon Linux EC2 instances, so I don't need to install the CLI now. Now let me install the Apache web server. Yum install httpd to install the Apache web server application, and let me enable systemctl enable httpd to ensure that the Apache web server is auto start after the restart or even when you are launching new instances by using the golden AMIs. Now let me install the Git. Yum install Git. The Git will be required to download the source code that is available in our Bitbucket repository in this particular project scope. Now let me install the CloudWatch agent. Yum install Amazon CloudWatch agent. Well, once the CloudWatch agent is installed, then we need to ensure that the CloudWatch agent also set to auto start, right? Systemctl enable and Amazon CloudWatch agent. Good. Now we need to ensure that the custom memory metrics of this EC2 instance is pushing to the CloudWatch metrics group, right? So let me go and configure the custom memory metrics. As you know, CloudWatch is not supporting to collect the memory utilization of your EC2 instance by default. So we need to have a custom configuration deployed to make this working, right? So all the steps what I'm following here are already documented in a step-by-step approach in the edueki.com. You can refer through this particular tutorial page to know the instructions step-by-step mentioned here, including all, right? So at the moment we are configuring the custom memory metrics configuration, right? So we need to configure the memory configuration, how it has to push the metrics to the CloudWatch, right? So we can find the configuration here, which we need to add in the config.json, right? So the same configuration, I have it handy available in my local Visual Studio Code editor as well to have or increasing the readability, right? So let me copy the same. Let me go back to the EC2 and let me open opt AWS CloudWatch Amazon CloudWatch agent. Then let me go to the bin location. Well, then let me create a config file. So config.json is the configuration file that I'm creating here, and let me keep the configuration here. Let me save this configuration, right? So now let me go back to the documentation just to ensure that we are configuring it in the right place. Yes. And if the EC2 instance has to push the custom memory metrics to the CloudWatch, then the EC2 instance would need a IAM permission as well, right? So let me create a required IAM role that I can use later, correct? So as of now, I don't need to attach the IAM role to this instance as I'm just keeping the configuration to create a golden AMI, right? So, but I'm preparing the required necessary role permissions as well for now. Okay. So let me go ahead and create a IAM role that I would need, right, for my EC2 instances so that I will not be missing these prerequisites. So I'll go and create a IAM role. Let me select create a role. The trusted entity will be AWS service. EC2 is my trusted entity to which service that I'm going to use this IAM role, and click on next. Now let me attach the required policies, guys. So I would need the CloudWatch access, right? Because I'm expecting the metrics has to be pushed to the CloudWatch. So let me search for the CloudWatch policy. Let me select the CloudWatch full access policy and go to next. So I'll give the role name as ED EC2 global role, right? And let me go and create a role. Well, now the role is getting created for me. So once the role is completed, then I'll go back to my steps. Done. Now, as per this, I think the required agent is installed. The configuration is also ready in the default location. It's all good. Now I need to install the SSM agent, right? Yum install Amazon SSM agent. So you see that the agent is already installed, so we don't need to do any further configuration on this. Good. If you wanted to verify whether the custom memory push is actually working before you start creating a golden AMI, you can even look through that, right? So systemctl start Amazon CloudWatch agent. So I'm starting the services. Now let me verify the status of this CloudWatch agent. Well, so look like the agent is not started. Let me look into it. Well, well, the agent is not started, right? So let me looking into the logs. I'll go to the logs folder. Now let me see the log file name. Let me look into the log why the agent is not started, which is complaining that it is trying to read the configuration from this default location, but we have copied it into the different location, so it is not picking. So let me copy the configuration to the right location. I think we copied it into the bin location. So let me move this file config.json to the specified default target location, right? Now let me try to restart the service one more time. Systemctl start Amazon CloudWatch agent. There is a typo. Let me specify Amazon. Now let me verify the status one more time. status. Now I could see that the agent is started successfully. If it is pushing the memory metrics to the CloudWatch, then we should be able to see the CloudWatch metrics. Let me show you where you can find the memory utilization of a EC2 instance. Let me navigate to the CloudWatch service. Well, this is still loading. So under the CloudWatch, we can just go to the all metrics, and here you can see the different category of the metrics. Now I need to select the metric type as AWS agent. So let me refresh. Well, I don't find any AWS custom events here. So let me go back to the logs one more time, guys. It's always a good idea to verify whether it is working as expected or not. Well, the log says that there are no credentials required, to push the metrics to the CloudWatch. Obviously, as we have not started attaching a IAM role to this EC2 instance, right? So let me go back to the EC2 instance. Let me attach a role. But of course, you don't need a role to be attached just to create a AMI. But here we are validating the configuration is good or not before you create a AMI. Hence, we are attaching a role to ensure that this is working as expected, right? So let me go and attach the role that we have created some time back. EDEC2 global role. Done. Now let me go back and try to restart the service one more time. Systemctl restart Amazon CloudWatch agent. Let me looking into the logs one more time. Well, now I can see that it is successfully pushing the logs to the CloudWatch. Let me go back to the CloudWatch service and let me do a simple refresh here. Well, now I can see the CW agent is appearing here, which is a custom namespace, and I can see there is one instance that is registered here to show you the memory utilization, which is your temporary EC2 instance. Now I can see the memory utilization of this EC2 instance in the graphs. It is just started, you don't see much information in the graph, but yes, the good thing is it is actually showing your EC2 instance in the list, so you will be able to see the memory pattern of this server in a while. Good. Now let me go back to the problem statement. With this, I have completed all the required prerequisites packed into your EC2 instance, right? So let me go and select the EC2 instance and you know start creating a golden AMI out of this. Select the server, actions. Let me go to image and templates and click on create a AMI, which is EC2 web server AMI. So let me give the same thing as a image description too. I don't want my EC2 instance to go to a reboot during the AMI creation time. So let me click on create a image. Yes, the image creation is started. Now let me go back to the AMI tab here to see the AMI. Yes, the image is in the process of creation. This is good. So I just need to wait for some time so that the AMI will be available for us to use further in our project. Good. So let me proceed with the next, and this is where we are deploying the VPC, and these are the different steps that we need to follow to deploy the VPC, guys, right? So let me follow one by one. So first I need to build a VPC with the required CIDR range, which I'm going to use for the bastion host, right? So let me look into the architecture one more time, and this is the VPC that I'm deploying, which I can use to deploy my bastion host, right? So simply I'll go and create a VPC with the specified CIDR range, right? In my AWS management console, let me choose VPC. Now let me click on your VPC tab, where I can see only the default VPC. Now I'm creating my custom VPC here. So let's say this is a EDVPC01. Let me specify the CIDR range and click on create a VPC. Now the next step is we need to create one more VPC which we are going to use to deploy our EC2 instances, right? So I will go back and start clicking on create a VPC and specify the name as EDVPC02, give the CIDR range and click on create a VPC, right? Then it is asking us to create a NAT gateway, and to create a NAT gateway we need a public subnets, right? So to meet this third step, let me go and complete the remaining dependencies as per this architecture, right? So I have two VPCs. Now I need to have one public subnet in the first VPC, right? So let me go and do the setup, guys. I definitely need a internet gateways for these two VPCs in order to provide a internet connectivity. So ED for VPC01, I need a internet gateway, right? So this internet gateway I'm attaching to the VPC1. Then I'm creating a one more internet gateway for my second VPC, ED VPC02 IGW, and click on create a internet gateway and attach this internet gateway to my second VPC, right? Now let me go ahead and start creating the required subnets. First, let me create a subnet on VPC1. Let's say this is ED a subnet. I'll call this as a public subnet 01. I can deploy it into 1A availability zone and 192.168.1.0/24 will be the CIDR block. And let me create a subnet. So as per this architecture, I have created one subnet in my first VPC. Now I need to have two public subnets in the second VPC, right? Let me go ahead and do that too. Create a subnet, select my second VPC, and let's say ed public subnet 01 in 1A availability zone and 172.32.1.0/24, which is the CIDR range falling within the VPC, right? And let me add a one more subnet, which is ed public subnet 02. I can deploy this in any zone. I'll go with 1A zone and 172.32.2.0/24 is the CIDR block, and let me create these two public subnets. Now I just need to have two more private subnets that I need to deploy my EC2 instances, right? Let me do that. Create a subnet, select the second VPC, and ed, this is the private subnet 01 on 1A availability zone, which is 172.32.3.0/24. Create a one more subnet, which is ed private subnet 02. I can deploy this in 1B zone to maintain the high availability irrespective of the zone failures. 172.32, let's say 4.0/24, and go ahead and create these two private subnets. Obviously, when I have created a private subnets, these two private subnet would require a NAT gateway, right, to have a outbound internet connectivity. So let me create one NAT gateway in the public subnet, right? So I will navigate to the NAT gateway section here and click on create a NAT gateway. This is ed NAT gateway 01. This I'm going to deploy it into the subnets, right? So I'm going to deploy it into the private subnets. Okay. So let me see the naming standards here. ed public subnet 01, public subnet 0201. So look like there is a confusion in terms of the naming standards, right? Now I need to understand which public subnet is actually created in my second VPC, right? So let me cancel for now. Let me go back to my subnets here to see which is the right subnet that I need to create my public NAT gateways, right? So let me verify the VPC name here. ed VPC 02 is my VPC, right? And let me see the public subnet for that, right? I can see that ed public subnet 02, this is the subnet ID that is actually created it in the second VPC. So let me go ahead and create my NAT gateway in that subnet only, right? It makes sense. Now let me click on create a NAT gateway and let me specify the NAT name. Now let me select the subnet here and let me get the Elastic API as this is a public subnet NAT gateway, and click on create a NAT gateway. Good. Going back to the architecture one more time, I think this is all good, right? I just need a load balancer to be created in your public subnets. Then it will be great. So let me do that, guys, right? So I will go back to the EC2. I'm just trying to create all the required topology components, right? Whatever we see there. Okay. So of course, before we move on to that, I really wanted to create a route tables. The problem statement is not giving you a step-by-step approach what needs to be done, right? By looking into the step, we need to understand the dependencies and we need to configure the associated resources. I think before moving on to you know creating a load balancer stuff, right? The best thing is to complete all of our VPC related things. Okay, so let me go to the VPC back again and let me create a route tables, right? I just need total 3 route tables here, guys. Okay, so let me go ahead and create a route table. This is the route table for VPC01 for public purpose, right? Now my naming convention is very clear which route table for which use. Select the VPC01 and create a route table. Now let me create a one more route table. This is a ED route table on VPC02 for a public. Select the second VPC from the drop down and click on create a route table. Now let me select a one more route table which is a ED VPC02. I'm going to create this as a private route table 01, right? So let me select my second VPC. In my second VPC, this is the private route table. I can have only one route table for my private purpose. Click on create a route table, right? Now let me go back to this route table list and I need to configure the routing entries, right? So for my private route table, I don't need to do any changes as by default the routes are added to route the traffic within the VPC, right? Good for now. And let me go to the public route tables. For public route table, we just need to add a route routing the traffic to the internet gateways. So by default, the traffic should go through the internet gateway, right? Done. Now let me do the same thing on my other public route table too, right? And let me click on edit routes, add a route, default destination, the traffic should go through the internet gateway. Select the internet gateway and save changes. Good. Now the other thing is for the private route table, I just need to add a NAT entry as well, right? That's what we are missing. Edit the routes. The default traffic should always be going through the NAT gateway. So select the NAT gateway from the drop down and click on save changes. Now this private route table should be in association to the subnets too, right? Edit the subnet association and let me choose the private subnets in your second VPC, right? So the private subnet 01, private subnet 02, correct? Save the association. The same way, I need to associate our public subnets too, right? So let me select the public route table, subnet association, edit subnet association, and let me select the public subnet. And let me choose the other route table too, right? Subnet association, edit subnet association, and let me select the public subnet. So in this case, I have two public subnets and let me choose both of them to my public route table, right? Good. So I think with that, I think we have completed all of our network topology, right? In VPC. I think the time to get started with the transit gateway as well, so that we can complete all the VPC related stuff, right? So let me go and create a transit gateway which will be providing a communication between the VPCs using the private IP range, right? In your VPC, let me do a little scroll down and select the transit gateway. Here I can see the transit gateway option, right? So let me click on create a transit gateway, ED transit gateway, and I can give the same thing as the description too. Scroll down, and yes, I need to create a transit gateway. So let me follow these standards to give this ASN number and scroll down. That's it. Let me go ahead and create a transit gateway. And this transit gateway I need to use to my both VPCs, right? So let me go and attach this transit gateway to both VPCs. I can see here transit gateway attachments, and let me click on create a transit gateway attachment. Let's say this is a transit gateway attachment 01, right? Let me select the transit gateway from the drop down, and let me select it to the VPC, correct? So yes, my VPC is supporting for DNS. Let me choose the VPC 01 here, right? And yes, this is choosing the subnets. Now click on attachment. Now let me attach this to my second VPC too, right? So transit gateway attachment to my second VPC, select the transit gateway from the drop down. I wanted to attach this to the VPC, select the second VPC from the drop down, right, and proceed for attachment. Good. So now my transit gateway is being used by both VPCs, right? So let me see the transit gateway route tables. So I can see a route table here which is describing the way how, right, it has to be associated, right? You can see the details well. So for now, what I can do, right, I can just go back to my route tables and let my route table how it has to route the traffic to other VPCs. First, let me call out the private route table, right? So I'll go back to my private route table, right? So let me add a route entry here stating that if the destination is the opposite VPC, which is 192.168.0.0/16, correct? So currently I am in 172 series VPC, and if the traffic is has to go through the other VPC range, then the target will be a transit gateway, right? And select the transit gateway here and save changes. The same thing has to be repeated for the other route tables too, right? So let me go back to my other route table, add a entry here stating that if the traffic has to go through the opposite VPC, correct? So 172.32.0.0/16 is my other VPC because currently I'm adding it into my 172 series of route table. The traffic should go through the transit gateway and select the transit gateway that was already attached to that VPC and save changes. Now let me do the same thing for my other route table too, right? So let me click on edit routes, and opposite to VPC range is 192.168 0.0/16. The traffic should go through the transit gateway and select the transit gateway from the drop down and click on save changes. Good. Now let me go back to here. Look like we have completed the whole VPC architecture, right? Now let me look into the steps. Well, the third step is completed where we have created a NAT gateway. The fifth step is completed where we have created a transit gateways. We have enabled the transit gateway rules in your specific route tables. Now we need to create a CloudWatch log group with the two log streams to store VPC flow logs of both VPCs, right? Well, so this is all about uh, pushing your VPC flow logs to the CloudWatch log groups, right? Let's see how to push the flow logs to the you know CloudWatch log groups. So if you go back to your VPC and select any one of the VPC and just go here and edit the VPC settings, right? So I'm just trying to show you the option to enable the flow logs, right? So you can see here the flow logs, and this is where we need to create a flow log. The flow log is all about capturing the network in and network out details of this particular VPC, right? So let's say this is a flow logs 01, and yes, all the traffic has to be captured and the traffic has to go through the CloudWatch logs, right? And this is where we need to specify the CloudWatch log group name, in which log group you are expecting the logs has to be pushed. For this, yes, it is expecting a role has to be associated. So to complete this step, first I need to create a log group, then the IAM role. Let me complete that. I'll go back to the CloudWatch logs dashboard. It's a big project, right? So if you feel this is helpful, please do subscribe to this channel, guys. And let me go to the CloudWatch log groups here, and let me create a log group. I'll just go to create a log group. Let's say this is for flow logs on VPC 01, right? And let me click on create. I can create a one more log group. Let's say this is for flow logs on VPC 02 and create a log group, right? Now I can go to the IAM to create a role. The role is required to grant a permission to your VPC to push the logs to your CloudWatch log group. I can create a role by navigating to the create role and create a trusted entity. So this time the trusted entity will be a flow logs, right? You don't see this in the in the drop down. For now, let me create a trusted entity as EC2 and let me grant a permission called CloudWatch full access. Correct. Now let me go to the next. The role name. This is like VPC flow logs, right? And here you can see the trusted entities. We need to edit the trusted entity to, that's fine. It is not allowing me to edit here only. So what I do, I'll go and create this role. Then I will edit the trusted entity later. So create a role. Well, so while it is creating, let me see what is the trusted entity that I need to use over there, right? So I'll just search for a flow logs in my documentation because I just need to see the trusted entity that I need to use, right? Well, it's not listed somehow. Let me see if I have this in here. Well, I have already captured this in my local system. So this is the trusted entity that I need to attach, right? So what I do, I'll just go to the IAM role. So go back to the IAM role, go to trusted relationship. edit the trusted policy here. Now I can select the flow logs as the trusted entity. That's it, right? And save the policy. Now I can see the trusted entity is updated to the one which is accepting the flow logs, right? So this is where I'm talking about the CloudWatch log group access, and yes, we have given the full access. There will be no issue, right? Now let me go back to the VPC settings and let me refresh this. Now I can select the flow logs log group name and select the role, correct? That's it. Now click on create a flow log. The same way, now I need to create a flow log for my second VPC too, correct? So select the second VPC, click on flow logs, create a flow log. The name is, let's say, ED flow logs 02, and I wanted to publish this logs to my second log group that we created already, and let me select the role to grant the permission and click on create a flow log. Great. Now let me come back here and look like we are all done with the 7 steps. Now we need to create a security group for my bastion host allowing the port number 22 from public. Well, so let me create a security group now. Click on create a security group, and this is the security group for my bastion host, right? Let me give the same thing as a description and which VPC that we need to raise, guys. So VPC 01 is I'm going to use for my bastion host, and I wanted to allow the port number SSH from public because I'm trying to make this as a bastion host, right? Accepting the traffic from the public internet space. Now I need to deploy the bastion host in the public subnet with the elastic IP associated, right? Let me go and start creating a EC2 instances. As per this architecture, now I'm going to deploy this bastion host. Well, so I'll go and create one simple EC2 instance to be used as a bastion host. This temporary server can be deleted now because that was created just to create a golden AMI, right? So let me specify the name tag as ed bastion 01. Then I'm using Amazon Linux AMI, the t2.micro as the instance type. Let me edit the VPC settings. VPC 01. Let me select the public subnet. Let me use the existing security group that was created some time back, allowing the port number 22, and let all other defaults for now, right? Let me click on launch instance. Yes, the key pair has to be associated here. Now let me click on launch instance. Well, now my bastion server is ready. I need to attach a elastic IP to my bastion host so that the default public IP, right, maybe get removed or added as that is the temporary one. I can go and allocate one public IP which is the elastic IP, and let me attach this elastic IP to my bastion server. Select my bastion server from the drop down and click on associate. Good. Now coming back to the steps. Now I need to create one S3 bucket to store application specific configuration. Okay, let's go ahead and create one S3 bucket. So I'll go to the S3 now. Now let me go ahead and create one simple S3 bucket to store the configuration. I'll name it as, let's say, S3 web configuration project. Any name would be fine, but I'm just using this. And let me go ahead and create a bucket. Now I need to create a launch configuration or a launch template with the specified information that I can use for my auto scaling group, right? So let me go ahead and create a launch template, which is the new one which is recommended by the AWS rather using the launch configuration, right? So I'll go to my EC2 again, and here you can see the launch template option. Click on create a launch template, right? So let's say this is ED web launch template, right? So now let me specify the details. I need to specify the golden AMI from my AMI list, which was created some time back, right? Scroll down. Now the instance type is t2.micro. Let me choose the instance type as t2.micro as per the documentation. Let me choose the key pair name, and let me choose the network here, right? So I just need to select the network on my VPC 02, right? So let me go and choose one of the network here, the private network that I'm going to choose here, right? And let me choose the existing security group. There is one default which I'm going to use for now. I can change the rules later, right? And let it be all other defaults. So let me go back and see the golden AMI t2.micro. Yes, we need to have the user data script here to get the code has to be downloaded, right? So let me do that. I need to prepare a user data script, guys. Okay. So here you can see the user data script, which is, of course, is a best practice to update the system every time when it is coming up. And yes, we need to restart the HTTP services if need be. It's a best practice only, but the services are already auto start, but I'm just restarting them if any new configuration that you are loading it here, right? Now I'm just downloading the required file from my bucket, right? So here I'm using the code from my S3 bucket, right? I don't need to, right? I just need to download it from my Git directly at this time. Or you can even get it from your S3 as well. Look like as per this project specification, it is expecting us to get that file from the S3 bucket. But the config that you are downloading from S3 is not just a code. It could be any other configuration file too, right? So for now, let me use the same whatever is mentioned here rather using the Git concept, right? So then whichever the bucket that I have created here, I need to upload a simple index.html file, right, to complete this configuration. So let me go back to the S3 one more time. Right. So the bucket I just have created, I'm going to keep some index.html file over there. Let me upload the file. Let me add a file. Let me try to use index.html. I'm just uploading any one simple index.html file that is available in my local, and I'm just uploading that to here, right? So this is the bucket where I have uploaded my index.html file. Let me prepare this here. AWS S3 CP S3 colon / the bucket name index.html I wanted to download to where www.html location, right? So yes, I'm just restarting the services later just to ensure, and I think I don't need to uh, use this. Okay, so this is about the AWS logs agent, guys. So we have not installed this AWS logs agent as part of our golden AMI. Let me install this now, right? So yum install AWS logs. Then I'm going to start this particular service using systemctl start AWS logs D. This is required to push your application logs to your custom log group, right? So as I have missed configuring this in our golden AMI, I'm just installing this now. Good. So if your EC2 instance has to download the file from S3, obviously your instance should have a role associated, right? I think we created a role already, but I need to ensure what permissions are given over there, correct? So let me go back to the IAM one more time. It caused more confusion, right? Going there and here. Yes, that is how we are implementing the whole project in place, correct? So let me go back to the roles here and let me get my EC2 global role that was created initially. It has only the CloudWatch access, right? So let me go and add a S3 policy as well, right? So let me attach a policy, and you can even give the SSM permission as well if in case you wanted to access this from your session manager, right? So let me give the SSM permissions to here. Well, so I think this is all good now, right? So this role I need to use in my launch template, right? So let me go to the advanced details here and let me select the role from the drop down. Good. Now let me go down. In the user data section, I need to specify the script that has to be executed automatically in order to configure the server as fully ready functional to act as a web server, right? So I think that's what it is. Let me verify the things, guys, and I think the security group, we need to allow the port number 80 as well. The key pair is also associated. It's all good, right? So let me go and click on create a launch template. The launch template is ready. The one thing that I need to ensure is whether this security group is allowing the port number 80 or not. So I'll go back to that security group one more time to see the port number 80 is accessible, as I'm going to deploy a web servers in this particular EC2 instances, right? So I could see at the moment all traffic. I'm just trying to allow the port number 22 and allow the port number 80. So let me cancel this. I just have deleted the existing rules. Now let me try to add a rule again. Edit inbound rules. Add a rule. I wanted to allow the SSH and I wanted to allow the HTTP, right? And of course, the port number 22 would not be required, and allowing it for anywhere is also not a best practice. I'm just following the steps. Without a port number 22, you should be able to access your server from the session manager anyway. The port number 80 is mandatory, right? Well, it's all done. Now the time to start creating a auto scaling group, right? So let me do that. I think before me creating a auto scaling group, first I'll create a target group. the load balancer. Then I'll create a auto scaling group. Okay, so I'll go back to the target group section here. It's a big project, right? But it includes a lot of things. Create a target group, and my target group should have the instances as targets TG01, which is listening the port number 80, and it has to be deployed it into my second VPC, and let it be a default health checks, and go to next. I'm not creating any EC instances as a targets manually. That will be auto created by the auto scaling group. So the target group is created. Now let me go and create a load balancer. I can create a network or application load balancer, right? So for now, as I'm deploying the application there, so and I'm expecting the traffic on HTTP. So let me go ahead and create a application load balancer, specify the name of my application load balancer, right? This is the public load balancer. So the scheme is internet facing. It has to be deployed it into my second VPC, and it has to be deployed it into my public subnets, right? So select the public subnets from the drop down, right? So let me choose the public subnet from the drop down. So this is the public subnet 1, and let me choose public subnet 2. So let me see. Okay, so I'm not getting the public subnet in the drop down. Look like I don't have another public subnet created in 1B availability zone, right? I created both subnets in same availability zone, and hence it is not working. So I'll go back to the VPC one more time, because I just need to have another subnet in the second zone to have a two zones as a target EC2 instances, right? So I'll go and create a subnet here. Click on create a subnet. Select my second VPC, right? This is let's say ED public subnet 02 new, just for ensuring this is the new one, on 1B availability zone 172.32, let's say 5.0/24, right? And this subnet should be a internet facing. So I'll go back to my route table, the public route table on my VPC. Let me associate the another subnet as well here, right? So let me choose my new public subnet as well here in the list and save the association. Let me come back here. Now let's start identifying my other subnet. Possibly I just need to refresh this, select the VPC, right? Now let me choose the 1A zone, and let me choose the public subnet. Let me choose the 1B zone and the public subnet. Let it be the default security group, which is allowing the port number 80 as the listener configuration that has to be routed to the target group. And that's it. Let me go and create a load balancer. Now the time to go and start creating a auto scaling group, which is the last step in our project, right? So let's say EDASG-01. I wanted to use the existing launch template. Go to next. I wanted to deploy this into my second VPC. I wanted to deploy this into my private subnet 1 and the private subnet 2, right? So then go to next. So yes, I have the load balancer already. So let me attach this to the existing load balancer target groups. Let it be the default health checks, which is the EC2 health check, right? And let me go to the next. The one and the maximum, let's say 5. The scaling policies, yes, I'm configuring that if the usage is greater than 80, then it has to scale and can go maximum of 5 servers. I think, yeah, 4 is the maximum as per the project. Let me follow the same, right? So then let me go to the next, and that's it, right? So go to the next and go to the next. Let me start creating a auto scaling group. Then the next step is we need to add a CNAME record in my Route 53 routing the traffic to your load balancer, right? So I'll go back to my EC2 to get the load balancer endpoint that I can configure in my Route 53, right? So go to a load balancer there. Well, now let me select the load balancer. Let me get the DNS name and let me go back to Route 53, right? And let me add a record. If there is a record already, I just need to edit it, right? Pointing to my specific load balancer. I have the hosted zone already, which is stating at shopper.com. So let me see if there is a record already for www. I will be going to edit that, guys. Okay. So www.edshopper.com is now, you know, CNAME to your specific load balancer endpoint, right? With that, your project is completed, right? That means this project is all about setting up a custom VPC configuration and deploying a web server in a auto scaling group, load balancer in a private subnet, and giving the interconnectivity from the bastion to your private servers, which are in two different VPCs via the transit gateways, and enabling the flow logs, right? And configuring the remaining, right, the best practices as part of this, right? Now when it comes to the validation, right, so we just need to ensure the private servers are accessible via the bastion host, right? Let me see that, guys. I'll go back to my EC2. Let me refresh the screen. Now you see there is one EC2 server coming up, which is your actual web server created as part of your auto scaling group, right? So to do the first validation, first I'm logging into my bastion host using my saved profile. As you know, the bastion host will be accessible from public internet space, right? So that's the reason I'm accessing from my PuTTY directly. Now from here, I need to logging into my one of the private server to this private IP address, right? So let's say SSH, I wanted to log in as EC2-user to this private server. Yes, the connectivity is established, but the access is denied. That is expected, right? Because it need a key to logging in, right? So I have the private key downloaded in my local machine, right? Let me take that key and let me load that key in my bastion host. Then I'll show you how to logging into your private EC2 instances, right? So now vi, this is the key that I wanted to keep here. It can be in any location, but we need to explicitly mention the location when you are accessing. Ensure the permissions are secured. Now in your SSH command, I just need to specify that -i, then specify that which key that it has to use to connect. Here you go. The bastion host is in one VPC and the private server is in another VPC, but still you are able to access using the private IPs as the transmission is happening through the transit gateway. The validation one is completed. The second validation is you need to logging into the private servers using the session manager, right? So this is the private server. I'll click on connect. I'll use the session manager and click on connect. So this is confirming that the private servers are accessible using the session manager as the role is already associated granting the permission. That's it. That's it. So you don't need to log in via the bastion host. It is even possible to log in from your session manager as well. The third one is we need to browse your application, right? Let's see that. First of all, I need to verify the DNS is reflected, right? So the right command is nslookup www.edshopper.com. Let me correct this. nslookup, right? So you see it is actually resoluting it into your ALB. Now let me try to access this application, guys, right? So don't worry, I'm not using this custom code from the Bitbucket, so that's fine. So www.edshopper.com, right? Excellent. Now you see your edshopper.com is accessible. Don't worry what kind of website that it is loading here. So what was the code in your index.html that was kept in your S3 and it was downloaded, the same thing is coming in here. Even I was not checked in what code was there in the index.html that is actually got loaded here. Not a problem, right? So in your private server, you can go to var log location to verify that the user data is executed properly by looking into a cloud init log file, and you can see the different commands that are executed as part of your user data script, right? And you can see, right, it is downloading the file from S3, all those things. Good. Now I think there is one thing that I wanted to configure here, which is the pushing your Apache web server logs to the CloudWatch with the help of the AWS logs agent, right? So I'm not sure if that is specified somewhere here, right? But let me show you that how to do that, right? So I'll go back to your server, systemctl status AWS logsd. I can see this is already part of your user data, hence the reason the agent is already available here, right? So all what you need to do is you need to configure, right, which log file has to be pushed to your CloudWatch, right? So we can see the example configuration here, right? So let's say this is talking about the varlog messages file has to be pushed. Let's say in this case, I wanted to push my custom Apache log, varlog httpd access log, right? So varlog httpd access log, sorry, varlog httpd access log is the one that I wanted to push to my AWS CloudWatch, right? All what I need to do is I just need to, you know, open the AWS logs configuration file and specify the configuration details. Let's say I wanted to push my access logs, right? So this is my access log group name. You can put anything here, the name, the file, which file you are expecting it to push, specify the file name details here, right? Now save it. Systemctl restart AWS logsd, hit enter. Now if you go back to your CloudWatch, right, you should be able to see the Apache web server access logs that are pushing from your EC2 to your CloudWatch, right? So let me go to the CloudWatch log group here. Well, now you can see here var log httpd / access underscore log. Yes, this is the custom log that is got created, and this is where your log files are stored. You see, which is created your instance ID, and inside the instance ID now it will be showing all of your access logs, guys. So you don't need to go to AWS EC2 instance, you know, shell to get all these logs. All are now available in your CloudWatch itself for you to do, for you to investigate if anything has to be, right? Good. So that's how it is, guys. So now your, you know, your auto scaling is taken care of deploying these servers automatically, which is fully integrated in pushing the logs. And of course, right, this particular configuration should come from your golden AMI, but I just have added here because that is missing in the golden AMI. So update your AWS logs.conf in your golden AMI itself. That way, every time when the new server is getting launched, automatically the logs will be pushing to the CloudWatch, right? And the, you know, the other memory metrics also will be pushing to your AWS custom AWS agent 2 in your CloudWatch, right? We have already seen that in here. You see now the AWS agent is showing two instance IDs. Why? The one which you are, tested with the temporary server, and the other one is actually as part of your auto scaling. The instance ID ending with 41D is your server, right? And you see this, correct? So automatically every new server will be pushing the memory metrics to the CloudWatch, application logs to the CloudWatch, and we have followed all other best practice as well as part of this project architecture. Well, team, with this I'm done with the project implementation. I hope you like this project implementation guide, and which is involving a lot of services, including the AWS VPC, Route 53, ALBs, right? The target groups, auto scaling groups, S3, CloudWatch, alarms, right? The notifications, the IAM role, the flow logs, the lot of things that are involved here, including the transit gateways, the inter VPC, right? The connectivities, right? So go through this session one more time, guys, and try to implement it by yourself. If you have any specific questions, please add a comment to this video, or we can even comment it under this particular documentation page as well. Well, so if you like this video, please do share and subscribe to this channel, and we will be posting few more projects as well, right, which will be definitely helpful for you to increase your learning speed. Thank you very much and have a nice day.